with lunch almost. Thank you for taking your time out of your schedule, joining me here for a 45-minute on, well, Windows 10 deployment, more or less. I was asked to summarize the last 4 years of doing Windows 10 migrations into 45 minutes. So, challenge accepted. I managed to do it into one slide. Simple as this. It's a bit of work getting Windows 10 out there. And for the past 2.5 months, most of our team has basically been working double shifts or almost double shifts because it's like there is a deadline or something coming up shortly. And organizations have simply been late to the game, getting all their machines over from Windows 7 up to Windows 10. That being said, I absolutely love questions during the sessions. If you have any, I'll be happy to answer them. If you have any questions after the session, reach out to me. I'm fairly easy to find. Pretty unique last name. We're about 10 people in the world, and so far it's only 2 of us doing deployment, so fairly easy. Now, this is a community-inspired event, so get on Twitter, talk about the event, and have fun. So this is me. I used to be a fellow Swede. I moved to America, live outside Chicago. I'm old. I like old music. Recently went to see Iron Maiden in Dallas. It was pretty cool. I don't get it. Bruce Dickinson is like 61 years old. He's running around that stage for a good 2.5 hours. I'll be dead if I would do the same type of exercise. I like Star Wars. I write books. This is my blog. Done. So, I'd like to get a myth out of the way. Autopilot is a big buzzword. If you go to any Microsoft conference or you talk to any Microsoft sales rep, they're going to tell you that Windows Autopilot is the deal. That's the future. I'm not going to argue against that. But what it is not, it is absolutely not deployment. Autopilot is a technique to bring machines that you have under management one way or another. And Autopilot provides quite a different number of scenarios to do that. But it is not OS deployment. I promise you, if there isn't someone who puts Windows on the box, Autopilot is not going to work very well at all. And that someone is either going to be you, or it's going to be an OEM, or it's going to be a service provider that acts on behalf of the OEM. But Windows have to be on the box, otherwise we cannot bring it under management. Now, in the newer version of Windows 10, meaning 8.3 and above, the user experience is quite nice. I mean, the concept is simple. The core scenario for Autopilot is that you buy 10 machines from Dell or Lenovo or HP or whoever, and as part of that transaction, they will actually register that device on your behalf to your organization. So when that device is powered on the first time, it already knows it belongs to you guys. So you basically have to type in the password and a username and password and done. And the machine will sit there for 25 minutes, install some apps, and roll into Intune, get some policies, and then it's done. It's ready for use. Simple as that. So there are additional scenarios. There are like white glove scenarios where basically an IT person takes the machine and prepares it for the user. There are kiosk scenarios where you basically have self-deploying machines. I was working with an airline that was using this concept for their kiosks, the check-in kiosks. So if a machine broke down, they can just ship a new one, power it on, and it will just self-deploy with no action required, no login, no nothing. It just happened. Requires wired connection though. It doesn't work with wireless. Now, when we started to do Windows 10 migrations, I had a sort of an idea about what challenges we would run into 4 years ago. I figured that would be about the same as they were for Windows 7 because I've been doing XP to Vista, Vista to 7. I figured they'll probably follow the same path. As you probably realize, I was dead wrong. That didn't happen. Instead, we stumbled across stuff like this. Organizations were not simply ready for a Windows version being updated fairly frequently. They did not have the people in place, did not have the processes in place. They didn't realize that once a year or however often you upgrade, you have to retest every single hardware model that you have for drivers. Because drivers in Windows 10 are version specific. An older driver may work, but it may also require a new version of the driver. And it's not like you can go to Dell's website and say, all right, here's the matrix. I'm on Windows 10, 1709. I'm about to go to 1809. I have these 4 models here. Okay, which drivers do I need to upgrade? Which drivers do I need to remove? There is no such info. You guys are the guinea pigs. You have to do that testing. The same goes with applications. Some application support, compatibility levels, comes with a feature version 2. We had customers, for example, that were on 1607, but they couldn't go to 1703 because some of the most critical apps didn't work on 1703, but they worked on 1709. But how do you know unless you do that testing? I'm not asking you to test every single app because that's downright stupid. That nobody have time for that. But you need to test at least the most critical ones. Every version of Windows 10. So, how many organizations do you think upgrade twice a year? Nobody. Between a year and a half, that's what we typically say, or see, not say. So, say that you only do the upgrade every year or every 18 months, give or take. Is Windows 10 Professional a good license to use? It's not. Why? It's only supported for 18 months. And I hate to break this to you, but sometimes when Microsoft ships a new version of Windows 10, it takes a good few months and it actually becomes okay to deploy. So if it takes them 4, 5, 6 months to get it to a workable state, you already lost a few months out of those 18, and now you suddenly have to fast track everything. I recommend enterprise or education, depending on how you license stuff. Not only does it give you all deployment features and all management features, but also, as Sami was leading into this morning on the keynote, a lot of security features are only available on those platforms, enterprise and education. Windows 10 Pro simply don't have them. But they also get the 30-month support. And if you do a replacement or an upgrade every year and a half, having 2.5 years to your disposal is kind of nice. Because if one of the versions is not super good, you have time. You don't have to rush through things. So that's nice. Other things that organizations learn the hard way, and I've seen companies coming down to basically a halt in their entire network because they upgraded a little bit too many machines at the same time, and I didn't realize what Windows 10 was actually doing. Turns out that Windows 10 is a little bit more chatty, talkative on the network compared to Windows 7. Like a lot, like a 50 times lot more. So that's a big thing. So, speaking of that, you do need to do the testing. There are tools that can help you. You need to do the driver testing. There are tools that can help you. Now, it's been an interesting shift lately. Back in the days, I mean 3 years ago, Microsoft used to include a tool in the ADK called Application Compatibility Toolkit that could help you with this. That tool is long gone, will never come back. Instead, Microsoft replaced it with a cloud service. Upgrade readiness. Still around for a few more months, but it's being replaced with desktop analytics. So the thing is, if you go to the Azure portal and log in, and I go to my upgrade readiness portal, find my workspace here, give me a second. This will actually show you that it's time to replace this. Usually pop up a little bar and say, hey, you better move on because in 4 months, this will be replaced by desktop analytics. But both these solutions, you can still use the old one if you want for now, but they work the following way. You tell them what Windows version or what version of Windows 10 you're interested in going to, and these platforms will tell you how much work you have to do. I'll give you an example. If I scroll to the right here, see if it's not really optimized for a small screen, but I think you will get the idea anyway. But for example, in my little environment here, 2,000 machines, there are 140 known driver issues going to 1709. Okay, that's a number. Had it been 5, it's one type of work. If it's 500, it's a different type of work. But at least you can get some insights in how deep, not going to say that word, you are. How much work you have to do to go to the next version. Because there is a different story if it tells you that it's 5 drivers that needs to be worked on, or if it's 500. Or if it's 10 applications, or if it's 100 app. It's just a different workload, but it gives you an idea, all right, what are you up against? Other things is, and I happen to love Microsoft Paint, called Power Paint. I don't believe much in whiteboards, but I like this one. Pretty good at it now, I've been using it for a while. But imagine that you have a distributed environment, and quite frankly, a lot of customers are. Some have only a few sites, some have more. I've been working 4 solid months with a company. They have their head office in Germany, but they're a global company. 50,000 clients, 5,000 subnets. So it's a deep network, or big network. But imagine that it's Friday. You go, after the conference here today, you sneak by the office to check on things, and you decide to deploy a machine with Windows 10 1809, or you upgrade one of your old ones to Windows 10 1809, whatever you do. So, and you do this in the Utrecht branch office. So here's the machine that you deploy. And then, it's Friday after all, you go home, you leave it running over the weekend, and you come back to the office on Monday. The assumption here is that the Windows image that you deployed was already fully patched, fully up to date, latest security updates. But over the weekend, how much data will this machine download? It was already patched, remember that. So it's not a security update. It's going to download, give or take, 1.4 gigabyte. From where is the machine downloading that data? It's downloading it from internet. So here is internet. Told you I was good with paint. So you have an internet connection of some kind, I for internet. Maybe it's a shiny 45 megabit one, whatever. In the US, this is like considered good stuff. Here in Europe, people just laugh at it. But the thing is, the data actually goes from this client over your WAN link, over that WAN link, and back and down to the client again. All right, that was one machine. Now you upgrade 100. So you have 100 machines, each downloading 1.4 gigabyte over that link. What do you think your network team thinks of that idea? They do not love it. Absolutely. Not even in Finland do they love it, Sami. They don't. They get upset because you're killing the network, basically. So what Microsoft is doing to prevent this is obviously they want you to use peer-to-peer solutions so that only one client actually downloads the traffic. But here's the deal. Organizations, they didn't realize this. So they started to deploy and upgrade, and suddenly the network will just brrr. So I will show later how to fix this. But this was one of those things that they simply were not ready for. Big thing. All right. Luckily, deployment haven't changed much. We still have the core 4 deployment scenarios, very shiny. There is something that is almost OS deployment called provisioning packages. That was basically, I like to call this the first version of analytics or Windows Autopilot. The concept is you go buy a machine at the local gas station, it comes with Windows 10 Pro, it's not ready for your enterprise, but you give the user a USB stick with a package on it, and they double-click this package, and that package magically transforms your machine into a corporate device. Upgrade the SKU from Pro to Enterprise, installs a few certificates, join it to your domain, add an application maybe, but transforms that device into an enterprise device. Now we do that through cloud. So Windows Autopilot is the provisioning package, basically. But these guys are still around. So our team, by now, we have worked with a little bit over 120 plus customers for the past 4 years. We are not that big of a team, but been doing this for a while, so here it is. How many of them do you think did an in-place upgrade going from 7 to 10?
0.
Not 0. Not 1 either. 3. 3 did it. And it worked great. They did not skip the in-place upgrade because it's not working. The in-place upgrade actually works fairly well. It's been tested quite a lot. It turns out that one of my mother and father is one of the testers. 900 million consumer devices out there, and corporates are in that number too. They have been upgraded at least once at some point, so it's a lot of Windows 10 upgrades happening. So it's not like the process didn't work. So why did they not do it if it's working? Well, for a start, it turns out that this is my blog, by the way, Deployment Research. This is where I post most of the stupidity I'm stumbling across out there. But if you search that blog for limitations, there is a little post. Come on, internet, you can do this. Any time of the week. It's a long way to the United States, but it's not that long. Here we go. Only one more page. Here we go. So, for a start, you cannot use your own golden image with apps if you want to do an in-place upgrade. You have to use a clean media. You cannot, during the upgrade, convert the machine from BIOS to UEFI. And guess what? A lot of Windows 7 machines, like every single one, is on BIOS, because it's a royal pain to deploy Windows 7 to UEFI-based machines. So organizations, they did not. They are on 7. Now, you can do this afterwards, but the upgrade itself cannot do it. It can still be fully automated and should, but here's the deal. Also, if you have third-party disk encryption, oh my goodness, you're in for a world of pain. There is no fun doing in-place upgrades on those under that scenario. I'm not saying it's impossible, I'm just saying it's no fun. Third-party antivirus can also cause some interesting scenarios. And this was one that surprised me a little bit, but it turned out that a lot of organizations out there, back in the days, they thought that 32-bit versions of Windows 7 was a good thing to deploy, so they did, at least to some of their machines. Now they want to go 64-bit Windows 10, and you cannot upgrade. There is no in-place upgrade from 32 to 64. There are also some challenges around language, yada, yada, yada. So why do you need to bother? Can't you run Windows 10 on a BIOS-based machine? Why do you have to worry about UEFI? Well, turns out that if you search my blog for UEFI, and you try to spell it somewhat correctly, many of the new shiny security features in Windows 10, they kind of requires it. And this is just a short list, but as you can see, most of these are security features They only work if you switch to UEFI. And what about TPM version? What version do you run for Windows 7? You run TPM 1.2 typically. But Windows 10 kind of like TPM 2. And from a security point of view, it's quite a difference between version 2 of TPM versus 1.2. Put it this way, 1.2 is using SHA-1. What do we think about SHA-1? Not the highest security level. So there is a big thing of doing that. All right. So what I recommend is to find a platform that you like to deploy things with, like Config Manager. That's what I recommend. 75,000 customers are using Config Manager to deploy and manage Windows 10. 200-some million devices are managed by it. Today, it's the de facto standard on how to manage Windows 10. Microsoft has about a 99% market share. That's pretty good. For Windows 7, it was only 75%, but even 75% was pretty good. That means all other vendors combined are using that 1% left. So anyway, deployment scenarios. What I've been doing lately is creating what I call like Lego blocks, building blocks for the upgrade. Because sometimes, for example, when we do bare metal machines of Windows 10, we need to update BIOS. So here is a sequence that updates BIOS. And I can either deploy this onto existing machines right away, and they will upgrade the latest BIOS. Works with all vendors, meaning all the big vendors, Dell, HP, Lenovo. It will dynamically figure out what BIOS package it needs and upgrade it to the latest version. I can do that during deployment. During my bare metal deployments, if I deploy a new machine, it also gets the BIOS updated. Or I can do that as part of my in-place upgrade process as well. I mentioned the conversion from BIOS to UEFI. Why not do that? Here is a little sequence that reboots the machine into WinP, runs the micro tool to do the disk conversion, the disk layout conversion. Then I'm calling the different vendor tools to do the hardware configuration required for UEFI, the BIOS config. And then I reboot back into Windows. This entire sequence runs in less than 3 minutes. So this one I can either push out after having upgrading, or I can link my upgrade process to this sequence. So once the upgrade is done, it goes ahead and do the config. But you can't run this until you are on Windows 10. So easy enough. But of course, you can do other things. You have MBAM configurations you want to apply. You want to do some specific BIOS configuration. You might want to enable wake on LAN, whatever you want to do. You can just automate that entire process. So again, try to automate as much as you possibly can and have sequences do that job for you. Because this is just a workflow, just a list of actions that needs to happen in a certain order. The other option is, of course, to find the most suitable employee. Give him or her a pair of good Nike shoes or runner shoes and have them run around to every machine and BIOS F10 and click, 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 and do the configuration and go back. Or you automate it. The only thing that right now is a royal pain to automate is TPM upgrades from 1.2 to 1.2.0. Why is that a royal pain? Because vendors are so behind on this. Currently, 99.x% of all hardware requires physical presence when you do the conversion of TPM or upgrade TPM. So someone actually has to be there and press F1. For all other config of BIOS, you don't need to. The vendors figured out that years ago that you actually don't need to be present to do it. But for the TPM upgrades, you kind of have to. Just want to mention something. I did tell you that 3 out of 120 did the in-place upgrade. The other 117 was just not affected by the limitations I showed you. They also were missing a key component. happiness. They simply weren't happy with their current platform. They figured if they were going to Windows 10, they would be on Windows 10 for a while, like a decade at least. So they wanted to start fresh. They wanted to get rid of some of the junk they had on their machines. Maybe they wanted to go from a third-party antivirus into using Defender. They maybe want to go to use from a third-party disk encryption into using BitLocker, simplifying things. And then you really don't want to do an in-place upgrade. You want to start fresh. Set up a new platform and have that your new standard. So that's the main reason why they started to wipe their machines. But once you are on Windows 10, you don't wipe them once a year. Then you upgrade them. So, yeah. Anyhow. These are all technologies that you can use to reduce the network impact on Windows 10. I recommend to pick at least 2 of them. So, this one you must pick, because this is the only technology that can help you peer-to-peer updates for the native applications in Windows 10. And it's the only one that can do Microsoft Store updates, unless you actually download them first in Config Manager. And this is a big thing, because it's not only that initial 1+ gig download that happens, it's also the upcoming months. 300 to 600 megs every month are being updated. They will be released weekly, those updates, and not on the same day either. Just a constant data flow. So the reason we want to use peer-to-peer is obviously, so as soon as the first client in a location have the stuff, when other clients need it, they don't have to go over the network to get it. They can get it from a local friend. And that, if you do this right, you can actually reduce the network with about 90%. Once you start to get to learn how these peer-to-peer solutions work, this is the number that's your goal. I usually say if you go above 50, you're starting to get good at it, but 90% is your goal. And your network team will love you for it. But that doesn't help if your network team blocks it, which I've seen. They prevent peer-to-peer for security reasons. Right. I was working with an insurance company in the US, about 65,000 endpoints. They're known for their commercials. Their network team, in their infinite wisdom, decided to block this on the firewall level instead, because that kind of effectively stopped the traffic over the network. Yeah, but it also stopped the updates from coming down to the machines. So they were patching Windows, but they were not updating the 35 built-in apps in Windows 10, because they also get security updates. They get bug fixes, and sometimes there is an application like the news application actually requires a backend service from someone. What if that someone changes their backend service? So they need to update the client app to be able to talk to the backend service. So now we have broken apps also. I have organizations removing Xbox, because Xbox is bad to have in a corporate machine. Except that the Xbox identifier component is used for the photo app. So you break the photo app if that component is removed. So it's a bit tricky, and you can't really remove everything. And what's left behind, you better patch. I mean, what would your manager think if you, or a security person think if you told them that, all right, I have a machine, it's fully patched, almost. I decided not to patch half of it. Good? That is not good. So DO will help you peer-to-peer updates for Windows. These 2 will help you peer basically everything else, especially if you have a config manager. This little friend requires config manager, this little friend does not. But it basically is all about reducing the network impact. This sounds like a noise a pig would say, or sound. That's a delivery optimization in network cache. If you have config manager, it's a checkbox on your distribution point. What it means that you now can be Microsoft, sort of, but you can have a server on premise, so that when a client here wants to download stuff, it will go to this server and say, hey server, can you get this for me? And the server will go get that update from Microsoft, put it back in its own cache, and at the same time stream it back to the client. Now, they still will peer-to-peer happily, but at least now they don't have to go over the internet link to get the stuff, assuming that the cache server has it. So every DP that you have with config manager can now enable doink, and it will start to cache stuff locally in your environment instead of each machine having to download over internet. So that's a good thing too. These two are interesting. This one is used to throttle traffic so that you don't nuke your WAN links when downloading stuff. This one is for the exact opposite. It wants to use as much as it can of your WAN link. With this one enabled, approved traffic will go full steam ahead. And this is typically traffic between the config manager client and a distribution point. If something else needs to happen on that network, like someone is doing a Skype call or copying a file or browsing a website, it will hear that, detect that, automatically back off, allow that traffic to happen, and then go back to use the WAN link 100% again. So when enabling this on all your distribution points, you get a much better utilization of your WAN links. Like they're being used all the time. You get what you're paying for, but they're not killing the traffic that needs to happen. It will back off if other stuff needs to go there. So this is like a, I don't know, reverse quality of service type thing, but it's working remarkably well. See a lot of improvements, especially as your company grows. All right. So, oops. Once you start to set this stuff up, if you are a smaller environment, it's not big of a deal. You can actually get some, that's my patch level in the lab, by the way. It's not very good right now. The main reason those 17 machines are not compliant is because they're turned off, so no big deal. But client data sources will tell you how your network is doing. So this is a network where we basically have no peer-to-peer happening at all. You want this to be the opposite. But you can use this one to figure out how good it is. If you look at this instead, where do I go? Oh, here. Journey. I absolutely, what? Wi-Fi on conference networks. Try again. I absolutely hate that they removed all the blogs they used to have on TechNet and they moved it over to Tech Community because now it's impossible to find all the stuff again. So anyhow, Microsoft did a blog post last year around their own journey to do peer-to-peer. And the screenshot is terrible, but you can kind of see that even in their pretty large environment, 300-some thousand clients, they are in well over, if you combine branch cache and peer cache, they are give or take 93% of all traffic comes from peers, not from distribution points, not from servers. So that's the amount, but if you look at the core numbers, you see that they actually have about 2/3 of their machine using peers for the majority of their connections, but about 78,000 of them is contacting a DP. But this is your goal. This is what you want to strive at. Try to offload the service from traffic and try to make use of the switches that you have in your local offices to prevent updates from basically nuking your network. All right. Once you are on Windows 10, it's kind of important to keep it somewhat updated. Called servicing, it's called in-place upgrades, same thing. Microsoft have the sort of a quote or statement they call it, get current, stay current. This is the stay current part. or stay current for it. There are two ways to keep Windows 10 fairly up to date. One is to use service plans. One is to use sequences. I recommend this one, because this one is typically the only solution that allow you to come down to a 2-3% failure rate, which is, by the way, considered state-of-the-art, by the way. Most organizations are in the 10% failure rates. So if you have 1,000 computers that you service, would you rather like to debug 20 or 100? 2% versus 10%. I would say I prefer 20 to troubleshoot, because there will always be something that happens. I know that, but sequences is the only way to get some decent control of this. It's not the only way, but it's a good way. So when we started out doing deployments back in 2015, 2016, Windows 10, we would use a single sequence for everything, like this one. So we will have a single task sequence that we push out to the environment. The sequence will do a bunch of validation steps. It will do the actual upgrade, and then we would fix everything the upgrade broke afterwards. So that was the process. But we were using this flow to make that happen. We don't do this anymore. We changed into 2 sequences. So now we have a validation sequence and we have an upgrade sequence. In the validation, we do many, many more tests. And we do also fair amount of cleanup before we do the upgrade. Because one of the main reasons an upgrade will fail is because it's running out of disk space. Microsoft will tell you 10 gigs is enough. It's not. Try 25 gigs and you are fairly on the track. So do some cleanup. Another reason the upgrade fails is because you have 65 profiles on the machine, because it was a shared computer. And now the upgrade process have to go through each and every them and try to upgrade. If it happens to succeed, which is very unlikely, it's going to take 3 hours for it to do it. But normally it just breaks when it's too many profiles. So get rid of the profiles. I usually don't use scripts for this, but if I have to, I will do it. I like to use a group policy for this, because there is a setting in group policy where you can configure and say, hey, remove profiles that hasn't been used in like the last, 6 months, give or take. And some additional readiness, yada, yada. And then we do a fake upgrade. We do an upgrade without doing the upgrade. We basically tell setup that, all right, what if I would upgrade this machine? What would you think about that? And the setup is going to give you either a thumbs up or a absolutely not. So this sequence we push out first. We push out it silently, we tell nobody, we show no progress, we just do it. Because this one is going to come back and say either yes or no. And we configure the platform in a way so that every machine that failed the test will be automatically added to a machines that were not ready. They will show up in this collection if the first validation sequence fails. And now obviously you need to dispatch some people to fix those machines, but at least you know about it. The one that passes the validation will be automatically put into this collection. And it's to this collection I deploy my real upgrade sequence. But what we also do for the in-place upgrade sequence, the validation part, we have it pre-cache the content on the hard drive as part of the validation. So everything we need to do the upgrade is actually on the disk. And that makes the setup of the upgrade as fast as it possibly can be. We validated that the machine is okay. We got rid of all the junk. We put the content on the hard drive. It's there. Now we can do the upgrade, and we can have an upgrade running in between 30 minutes and 60 minutes. It's nice to the user, less intrusive to the user. What we also do, of course, is, let me see here. It's kind of stupid to search for a sequence in the wrong workspace. How about that? So when we're doing the upgrades, we also do some clever stuff, like we figure out what power plan the users were having, make a note of that. Then we flip the machine into high performance. That's the non-tree hugging mode, and allows us to run the upgrade as fast as it can. And when we're done with the upgrade, we flip back to the performance mode the machine had before. Because again, we want it to get over. It's like ripping a Band-Aid. We want it like done in a second, if possible. So that's the story there. Now, 1909 is literally around the corner. It's here, 1909. What's different between Windows 10 1909 and 1903 and 1809? Feature support, the way it's being serviced. Here's the deal. If you are on 1809 and you want to go to 1909, it's the usual whole in-place upgrade using a sequence, service plan, whatever thing. If you're 1903, it's just a big fat patch. They have the same servicing stack in 1903 and 1909. So I think this is, I haven't got it confirmed, but my gut tells me that this is Microsoft's sort of little trick to I wouldn't say bribe, but convince you of upgrading more frequently. Because we usually don't have too much of a problem with apply a patch every month. But we do have a problem in doing a full in-place upgrade twice a year. So it'll be interesting to see going forward what this one takes us. But the number one complaint Microsoft have received to keep Windows 10 current is, why does it have to take so long time? We can hardly convince our users to reboot once a month. Wait 5 minutes. They don't want to wait an hour, hour and a half for an upgrade. What I do recommend, if you're starting to go through the upgrade route one way or another, there is a gentleman named Martin in Denmark. Notifications, Windows 10. Come on. Google, you can do this. I thought. You're not hacking my machine, are you, Sami? Just checking. Anyway, he has a beautiful post, Martin in Denmark, search for toasts, on how to use the Windows 10 toast notifications, the one that you usually have showing up here, to actually display something nice to the users about the upgrade, giving them some time to postpone it, and etc., etc., etc. So, give it one more try, otherwise I will simply leave it be for now. Conference Wi-Fi.
Mine went to the wrong one first.
I thought I was the conference one. Yeah, Media Plaza, something, something. Just doesn't like me, that's all. All right. Anyhow, skip that one for now. Here's the deal. It takes a few minutes to learn about Windows 10 deployments. I'll be back here next year with PDS, the organizations behind this event, for a 4-day training on how to do this. And Next year it's not going to be so much of deploying new, but more on the servicing side of things. So if you haven't get a chance to get a good deep dive on that, I recommend joining us. It'll be great fun. We're here in the Netherlands, down in Collenberg. It's not too far from here. It's like a 10-minute train ride, give or take. But other than that, ladies and gentlemen, thank you.